final video in the hardware portion of our FTC YouTube series, created and hosted by Team Ultra 10539. In this video, we'll discuss several of the common problems you may encounter with your hardware and how to fix them. I'll include timestamps in the description for how to fix each type of problem. The first half will focus more on the physical hardware of the robot, and the second half will focus more on errors you may see on the phone. In terms of mechanical problems you may encounter on your robot, problems with chain are among the most common. Chains are very hard to tension properly and sometimes do not work at all. If you're having problems with chains slipping along their sprockets, you'll need to make sure that it is tensioned properly. The way that you do this is you want to make sure that your chain is, number one, not placed in an orientation sort of like this. If your chain is in an orientation where the bottom sprocket is directly underneath the top sprocket, or even slightly off to an angle where it's significantly farther below, the chain will often slip over the bottom sprocket as there is not enough, as the gravity will pull the chain down and will loosen its grip on the bottom sprocket. So if you have that kind of orientation, it would be best to move the sprockets entirely. If your chain is too loose, what can happen is that the chain will skip on the second sprocket on the bottom, or on one of the sprockets, the driven sprocket, because the chain will be easily sliding off of the sprockets. This is a problem because obviously you don't want your chain to fall off during competition. If your chain is too tight, which is another problem, then the motor may have trouble driving the chain. If you notice, when I tighten this chain, I can now barely turn it at all because the chain tightness significantly increases the friction. You want to make sure that your chain is a balance between these two, sort of having a slight droop in the middle, but not too great, such that the chain is loose enough that it does not have a ton of friction, but also tight enough that it doesn't slip over the second sprocket. This would be about the optimal situation in which you'd want your chain. Many teams who have problems with their Mecanum Drivetrain not strafing properly have to deal with the problem of the wheels being not oriented correctly. In order for your Mecanum Drivetrain to work, you must notice that the wheels in all four, two of the wheels are the same and two of the wheels are different. If we notice, these two wheels are the same and these two wheels are the same. They must be oriented in such a way such that if you look at the rollers and the directions that they point, they form an X. When looked down from the top or from the bottom looking up, they must form a circle like this. If the rollers are not oriented correctly, then your robot will not be able to strafe. Secondly, if you have too much weight over one of the particular wheels on your Mecanum Drivetrain, that side will grip the ground much better, and therefore your robot will not be able to drive in a straight line or be able to strafe correctly. So, you need to make sure that you have a roughly even weight distribution across your robot in order to be able to strafe or drive in a straight line, especially with the Mecanum Drivetrain. If your robot is not able to drive properly, you should try using this particular example code, which I'll also include in the description below, to see if your robot is working. This code is guaranteed to work, so as long as you configure it properly, labeling your motors correctly. If you're having problems with your servos not working, you might want to try first making sure that you've plugged them into your expansion hub correctly. Making sure you line up the white wire on your servo with the white tag on the servo port, which is on the right side of the port. Making sure the white wire goes into that port. Again, if you're using a yellow wire servo with yellow, red, and black, make sure the yellow wire is where the white wire is in this case. If your servo still doesn't work after checking the orientation of this cable, make sure that the servo actually works by turning it manually. If the servo makes any clicking noises or seems to stutter a bit when you're turning it, that means your servo is likely broken and should be replaced. If it moves smoothly, then you should try using your SRS programmer, if you're using a Rev Smart Robot servo, to test it. If you're using a different type of servo, then I would recommend, if it still does not work at this point, to just exchange it. If you're using a Rev Smart Robot servo like this particular one, you can use the SRS programmer to do further testing. Unplug it from your expansion hub and use the SRS programmer instead. The SRS programmer, which I have here, basically allows you to control the servo much more precisely than the expansion hub does. So, you can plug in your servo here, making sure to line up the white wire with the S indicator on your SRS programmer. And first of all, just try pressing the test button. If your servo moves like this, that means that your servo is working properly. If your servo does not move like this, but instead moves continuously, then you likely also have a servo that is set to continuous rotation mode with this switch here. If you want to set it back to servo mode, all you need to do is change the switch to S, press the program button, then turn the servo a little bit to one direction, press either the left or the right buttons until the light lights up, turn the servo the opposite direction, press the other button, then press program, and your servo should be returned to servo mode. If you now press test, it should now work properly. If it does not work properly at this point, then your servo is likely broken and should be replaced. Another problem you may encounter with servos that you're using on your robot is that you use two long screws in order to mount servo horns to your servos. If you use a screw that is this long, you will damage the internal gearbox of the servo and it will no longer work. You should make sure to never use screws longer than this in order to mount servo horns. If you use a screw this long, the screw will pass down into the gearbox inside the servo, and the servo's gearbox will be destroyed. So do not use this kind of screw. Use these in every single case. If motors on your robot are stalling, then you might have a problem with your gear ratios. This particular motor that I have here contains a 5-to-1 gearbox and a 4-to-1 gearbox. Since the gearbox ratios multiply, this gearbox in its entirety is a 20-to-1 gearbox. A 20-to-1 gearbox is characterized with high speed but also low torque. So therefore, you should, if you would have a very heavy load that is causing your motor to stall, you should try using a larger gear ratio that has a higher number. This will maximize the torque and minimize the speed, and will ensure that your motor is able to lift a heavy load. We used this on our wobble goal arm this year, in which we had a 125-to-1 motor that was able to lift the wobble goal over the wall. One of the most common problems you will encounter when using the robotics phones in order to connect them to each other during a competition or whenever you're using your robot is that they will refuse to connect with one another. To mitigate this problem, all you need to do is you need to exit the phone apps and you need to go to settings on both of the phones. This will vary by device, but you want to go to network, in this case Wi-Fi, and you want to go to Wi-Fi preferences, go to advanced, and then go to Wi-Fi direct on both phones. Now you'll notice that in Wi-Fi direct, I can already see each of the other phones available here. So what we need to do in this case in order to make them connect is we need to tap to connect on one of the two phones, and we'll notice how there's an invitation to connect that pops up. We have to press accept here, and the two phones should connect. This may take a minute, and suddenly now it says connected here. You should make sure that if something like this goes wrong, if it continues to not connect, clear all of the remembered groups in this section down here, and then reconnect them again. Once the phones are connected, another problem that you may encounter is that a warning pops up that says Rev Robotics USB expansion hub portal is unable to open. Now, this indicates that your robot is unable to communicate with the expansion hub. Now, in my case, it's pretty obvious why this is happening, because the expansion hub is just simply not plugged into the phone at all. But even if I plug in the expansion hub, sometimes it will still give me this error. And this may happen for a variety of reasons. If you just recently changed the expansion hub on your robot, this error will pop up until you do a new configuration. So in my case, this is a new expansion hub that I have not used with this phone before, so I just need to create a new configuration, press new, scan, and in my case, I don't have anything plugged in, so I'm not actually going to write a configuration. I will just save it here as Q, and then I will just press OK here. And now, that error will disappear as soon as the robot restarts. Now another problem has popped up here. It says that the expansion hub reported that the battery is too low to run motors and servos. This indicates that the battery is actually just too low, and all you need to do is either to turn on the robots, that means your power switch is probably turned off, or you just need to plug in your battery. So in my case, as soon as I plug in this battery here, the robot, that error will go away on the phones. You notice now, the warning is popping up that says that both the robot controller and driver station support 5 GHz, but the robots and phones are selecting a 2.4 GHz channel. This is not really a big deal unless you're at a major competition, but at a major competition you might want to use a 5 GHz Wi-Fi network as opposed to a 2.4 GHz Wi-Fi network to avoid Wi-Fi interference during your matches. Now let's say I wanted to run an op mode such as a teleop. I can select my teleop and press init. Now I got a certain error here that says that the user threw an uncaught exception and that a certain device with the name flywheel could not be found. Now this happened because I have not set my configuration correctly. My configuration does not have a certain flywheel in it, so therefore the robot is unable to find the flywheel which the program is asking for. So therefore the robot will cause an error because there is a null object where the robot is trying to find an object to reference. As with many errors like this, you can read them and generally deduce what they mean. Most of the time it means you haven't initialized something properly in your code if you get an error that says that there is a uncaught exception that is a null pointer exception. So just make sure that in your program everything is initialized and everything is working properly. All the variables are correctly set before you run them through any part of your code in order to make sure that this works properly. I hope this video helped you understand a bit more about all the problems that you could encounter on your robot and how to fix them. If you have any specific problems that you'd like some extra help solving, please don't hesitate to reach out to us at ultra@browning.edu or leave your question in the comments down below. Thank you very much for watching.